Hi everyone, my name is Xiao Yishi, and you can call me Shirley. And my topic for today is forest level models and challenges for their successful application. During the last decade, we have progressed from small spectacle type supply models with simple habitat constraints to large, multiple objective forest level models that includes the landscape pattern and structures. However, we often lack credible scientific data to support these models in management applications. The objective of this paper are to summarize the current state of forest level modeling and to identify the challenges that lie ahead. The paper is intended to provide researchers with forest level modeling research needs, guidance to analysts for using these models widely. First, the author describes the suite of heuristics that are used in statistical modeling, and then focus on simulated annealing. This section includes a discussion of model parameters and the importance of parameter section. So selection, sensitive analysis and modeling verification. Second, the author describes how a forest level model must fit within a hierarchical decision support system. The need for advantaged data management to support the decision support system is identified in this section. In the third part of the paper, the author examines the scientific credibility of the forecasts generated by his models. This section covers the quality of input data, uncertainty, and how we interpret results. In the final section, he gives us the conclusions and identify challenges for the future. For the first topic, the heuristic, integer solutions to the harvest schedule problems are found using two general methods. One is exact and another one is heuristic. The pair of exact methods such as integer programming and dynamic programming is that their solutions are optimal, but the disadvantage is that problem size is limited. Solutions formed through heuristic algorithms are not necessarily optimal, but they are computed more quickly and can be used to solve much larger sized problems. Okay, the soft heuristics. The soft heuristics such as simulated annealing, taboo search, genetic algorithms, and evolution programming all employ random moves. Groundbreaking work by Lockwood and Moods used simulated annealing to model opening sized on a large forest with over 27,000 sanders, more than 15 times larger than your problem size. Tool such as has been used for road access problems in forest level modeling. Researchers also used combinations of different algorithms. The parameter, no, sorry. The soft heuristics have come to dominate both practical applications and the literature related to forest level landscape modeling. Next topic is parameter sections and Turing simulated annealing. Multiple objective heuristics like simulated annealing requires two sets of parameters. First, there are parameters associated with the objective themselves. For example, we need to specify a target for each objective, assign penalty functions to evaluate deviation for these targets, and weight these penalties relative to the other objective. Another parameters is associated with the cooling rate. The parameters are initial temperature T and the reduction factor R. This picture shows a simple problem with 5 objectives. Table volume, interior forest area, road budget, opening size, and area in early stage. For each objective, penalty functions tally the total penalty associated with deviations from the respective targets. These values are multiplied by the relative weight for each objective, and then summed to arrive at the total penalty cost. Like what we learned this semester, an initial temperature T and a reduction factor R with R larger than 0, smaller than 1. While T is not frozen, perform the following loop unwrapped times. Pick a random neighbor S prime of S. If S prime is feasible, let delta equals F S prime minus Fs. If delta larger than 0, update S equals to S prime. If delta smaller than 0, update S equals to S prime with probability E to the power of minus delta divide T. Update T equals RT. After the T is frozen, return the best result. This figure shows typical programs of maximization function for simulated annealing algorithm. As the number of iterations increase, the temperature drops, and the algorithm is less likely to accept an inferior move. Large gains are made in this early stage, and minimal gains are made in the late stages when the temperature is low. Next topic is sensitive analysis and a solution interpretation. Next topic is sensitive analysis and a solution interpretation. Failure to assess the sensitivity of the parameters can lead to both poor algorithm performance and misleading results. The trade-off are curved by Richard and Gum provided a good example of sensitive testing of their taboo search model parameters. A final challenge is to interpret in practical terms how to get from the current stage of forest to the final solution stage. This is not as simple as it sounds. Next section is hierarchical decision support systems. We need separate decision support tools at the operational, tactical, and strategic levels. The hierarchical approach also allows contiguous areas to receive special modeling considerations while modeling work on the remainder of the estate process. This picture the picture shows that the forest model also needs to be part of a decision support system because it depends on input from a critical set model and other models such as habitat and visualization are dependent on its output. Each model in system is complex in its own right and decide to answer specific question. Combining all those models into one would create an unmanageable monster, plus we would lose the flexibility to modify individual components. Equally important is the need for a team of experts in planning projects that can address specific issues related to each model. Next topic is scientific credible. The scientific credible of forest level model beyond verification depends on quality of inventories, completeness, and accuracy with which the illogical process are modeled, and approximate warning of uncertainty. A complete understanding of ecological process is therefore essential. Endemic disturbances can credible account for forecasting epidemic and catastrophic events have little credibility. The picture is shows that the map showing the worst case scenario for beetle infestation in the Lakes Tiber supply area. Dealing with uncertainty in a model is really challenge. Dealing with uncertainty that is a challenge. Our models only process forest case based on a set of assumptions, and that there are many possible outcomes that depends on factors beyond our control. There are also uncertainty induced by humans in the form of harvest technology markets and social and political change. To adhere to our plan to maintain credibility or to modify our plan to maximize benefits? That is the question. Another approach is search for flexibility and robust harvest schedule capable of withstanding such perturbance. Lower harvest rates and higher levels of mutual or near mutual growing stock can provide a buffer for these events. So finally, the analysis or researcher running the model is probably more important than the model itself. Okay, for the conclusion, that model heuristics are powerful tools for solving forest planning problems. However, these are highly complex models that must used widely. Sensitive analysis is critical to understanding the dynamic of the problems and the performance of the algorithms. There is no single optimal solution to these problems, and the researchers, analysts, and managers too need to understand this. We must also reflect on our limited understanding of forests in ecosystem process and beware of the inherent uncertainty in forest management, especially the magnitude of events such as fires and insects. The forest level models are just one component of the overall decision support system that is needed to address multiple objective forest management planning. A hierarchical system design is also needed to management data and model detail at each level. The decision support system must be built on an advanced data management system capable of handling very large spatial data sets. That's it. Thank you, everyone. Have good Christmas. Happy holidays.